Hello everyone, welcome to PJ Chemistry channel. Previous two videos we done based on 10th class, first chapter chemical reactions and equations. That continuation, today we are going to discuss what are the observations while reaction takes place. There are many reactions. While reaction takes place, something changes happening. That happening time, what are the observations? What are the measurable observations? Okay, that we are going to discuss. What changes you are going to observe? What are the observations while the action takes place? While the action takes place. What are the observations while the action takes place? Generally, what are the observations? For example, a simple. While rice is preparing, what are the observations you will means some vapors coming out while boiling, some sound you will get. Like this, we observe. Same way, while any reactions takes place, some changes we are going to notice. That first change is change in physical state. Change in physical state. Change in physical state. First change. What are the measurable changes? What are the observations while reaction takes place? Means first change in physical state. Any reaction. Okay. If you observe, there were changes. It's a physical state, solid to liquid in the product or gas in the product. Okay. So some examples for change in physical state. CaCO3, calcium carbonate. Actually, it is in solid state, white color. When it gets decomposed due to heat, it changes to calcium oxide, solid state. Carbon dioxide is in gaseous state. The physical state of matter, the physical state of particular substance, we are mentioning with small letters. S means solid, G means gas, L means liquid, AQ means aqueous medium. Like that, we are going to mention. For gases, not only G, upward arrow symbol also we can use. Okay, that we will discuss. So here, solid reactant side, if you observe solid, product side, gas also present. That is the changes. Next, hydrogen plus oxygen. These both are in gaseous state. Hydrogen is a gas, oxygen is a gas. It turns into water, liquid form. So, like this, physical state changes we are going to observe. Next, the second one, change in color. Change in color. Change in color. Some reactions, it will change its color. Reactant to one color, product side, some colors we will observe. Such reactions, for example, here ferrous sulfate FeSO4 with a crystal form 7H2O water molecule, 7 moles of water molecule present in ferrous sulfate. So it will appear like a pale green, pale green, or dirty green also you can say. When we make it decompose, what happens means due to strong heat, normal heat means just it turns into colorless. If you give strong heat, what happens means this FeSO4, okay, I will write two steps reaction. First under normal heat, then strong heat. First normal heat, FeSO4 plus 7H2O molecule getting evaporate, gaseous state. Now this pale green or dirty green, it becomes colorless here. Colorless. Still you are continuously giving heat. Still you are continuously giving heat. After turns into FeSO4, second step reaction. FeSO4. We are giving strong heat. This FeSO4 further getting decomposition, it becomes like a Fe2O3 or like a rust SO2 SO3 sulfur dioxide and sulfur trioxide, two gases liberating here. Now here FeSO4 is colorless. Fe2O3 is a reddish brown color, rust color, reddish brown. Rust is in reddish brown. So reddish brown color. Yes. Once again I written here, change in color. Ferrous sulfate crystal, it is in pale green color or dirty green color. When we give normal heat, what happens means from that water molecule will get evaporate. 7H2O get evaporate. 7H2O will get evaporate. It turns into gaseous state and it go out. The remaining residue FeSO4, ferrous sulfate, it becomes colorless. So until water molecule present in that, it appears like a pale green or dirty green color. Once water molecule escape from that due to heat, it becomes colorless. Now, after become colorless, still you are continuously giving heat, strong heat. Further reaction takes place. That FeSO4 will get decomposed like a rust Fe2O3. Rust is in which color? Reddish brown color. So reddish brown. So keep in the mind. 10th class mainly they will ask. See for CBSE students especially, Here we are writing like a just equation, but they will create like 5 marks question. X is an element, sorry, X is a compound which is pale green color. When it get decomposed, it gives compound Y which is in reddish brown color, and two colorless gases Z and W. What is X? What is Y? What is Z? What is W? Right there, balance the chemical equation and explain type of reaction. Like that, they will create questions. So here, just you have to remember what? Under normal condition, what products are appearing, what color changes happening. When we give strong heat, what happening? These observations clearly, if you keep it in the mind, very easy to overcome that question. So X is a compound, they only given hint, pale green color. Okay, FeSO4 7H2O. When it get decomposed under strong heat, it forms Y, which is in reddish brown color. It's nothing but rust. Next, two gases Y, Z and W, sulfur dioxide and sulfur trioxide. Write the chemical equation, balanced chemical equation. Okay. Okay. Now, next one more example. If we take copper nitrate or lead nitrate, PbNO3 twice. PbNO3 twice. How to write the formulas? First video itself we discussed. Okay, PbNO3 twice. 10th class first video. When we give heat to this, it decomposes into lead oxide, nitrogen dioxide plus oxygen gas. Oxygen gas. Balance this, just multiply with 2. About balancing, next one more video we will do. There you will get clarity. So lead nitrate is a colorless salt. Colorless salt is nothing but white color appearing. When we give heat, it turns into yellow color. Yellow color residue forming solid state. Don't forget to mention the physical state of matter, the particular substance. Nitrogen dioxide, NO2. Whenever nitrogen dioxide liberated, okay, that is a gas which appear in brown color fumes. Okay, nitrogen dioxide appears in brown color fumes. Brown fumes. So any hint given brown fumes means blindly can keep, that is nitrogen dioxide. Brown fumes. Brown color solid means rust. Brown fumes means nitrogen dioxide. Okay, these are the hints what you want to remember. Brown fumes, brown rust. Okay, brown color rust is solid state. Brown color fumes means nitrogen dioxide. Next, zinc nitrate. zinc nitrate, every year they are giving any one of this nitration decomposition as a lead nitrate or zinc nitrate or copper nitrate. Yes, same. Above reaction and this reaction. Only one element change here. Lead here, zinc. So if you replace lead with zinc, you will get answer. Here lead oxide form here, zinc oxide form. Remaining products are same. NO2 plus O2. NO2 and O2 both are gases liberation. Now ZNO under hot condition. Zinc nitrate is a colorless salt. It decomposes like a yellow color. Under hot condition, it appears yellow in color. And nitrogen dioxide means, like above discussed, brown fumes. Brown fumes. Oxygen is a colorless gas. Okay. These are some examples about color change. Again, we are going to discuss reaction wise. I will give more examples. Now, for each color, each change, we will take it one or two examples. Time not sufficient. It will become lengthy if we discuss more and more. Next, change in temperature. Before that, I will give evaluation of gas. Evaluation of gas means from the reaction, gas celebration means that all examples for evaluation of gas. Here only we discussed whatever change in color. In every example, gas liberation was there. So, same examples you can repeat for this also. Ferrous sulfate under strong heat, it decomposes into rust and two gases liberated, SO2 and SO3, sulfur dioxide and sulfur trioxide, which are give smell like a sulfur burning smell. While liberation, we will get that smell because both also colorless gases. Next, calcium carbonate also you can take, carbon dioxide releasing CaCO3, sorry, CaO plus CO2. Here also gas, colorless gas. Like that, even nitrogen dioxide, when it liberates, what color we observe? Brown fumes. Copper nitrate, Cu and O3 twice. When it gets decomposed, copper oxide, which appear in black color, nitrogen dioxide, which is a gas, reddish brown color, reddish brown, plus oxygen is a colorless gas. Like that, gases liberation. Next, silver bromide, which is in yellow color. In presence of sunlight, when it gets decomposed, sorry, silver chloride will take it. Bromine is in liquid form. Silver chloride. It is a colorless solid substance. It is nothing but white color. When it gets decomposed in presence of sunlight, it appears like silver gray in color and chlorine gas liberated. Chlorine gas liberated. This chlorine gas color is greenish yellow color. Greenish yellow. Okay, like this. Next, the fourth one is change in temperature. Change in temperature means here some reactions, when we supply heat or any energy, then only it will participate in the reaction. Some reactions without any additional energy itself it will participate in the reaction, and after reaction if you touch the bottom of the beaker, somewhat we feel hot, warm. That means from the reaction heat liberated. Like that, based on this absorbing and releasing, we are going to classify two types. If any reaction, to participate in the reaction, absorbed energy means endothermic reaction. If any reaction, to participate in the reaction, it is only released energy means exothermic reaction. Exhale, inhale, like. Okay, so change in temperature classified into two types. Endothermic reaction exothermic reaction. Exothermic reaction. First, we discuss about endothermic reaction. In endothermic reaction, first, what is meant by endothermic reaction? A reaction that proceeds by absorbing energy. A reaction that proceeds by absorbing energy are called endothermic reaction. Exothermic reaction. A reaction that proceeds a reaction that proceeds by releasing energy. By releasing energy. A reaction that proceeds by absorbing energy means endothermic. By releasing energy means exothermic. These are the definitions. Now, examples for endothermic. Dear children, here keep in the mind for endothermic. Easy to remember, all decomposition reactions are endothermic reactions. All decomposition reactions are endothermic reaction. What is decomposition reactions means? Upcoming videos we will discuss clearly about that here. Okay. All decomposition reactions are endothermic reactions. Keep in the mind. Common statement for all. Note. All decomposition reactions are endothermic reactions. Endothermic reactions. All decomposition reactions are endothermic reactions. This statement kept in the mind, very easy to find out. Endothermic. All decomposition reactions are endothermic reactions. Next, we'll go through the examples. For example, CaCO3, well-known example for everyone. When we give heat, it is absorbing heat, then it is getting decomposed into CaO plus CO2. Calcium carbonate is in solid state with flame, calcium oxide, carbon dioxide. Okay, here these products formed by absorbing heat energy. This delta symbol we are indicate representing like a heat energy absorbing. Okay, it is absorbing heat energy and getting decomposed. Next, water. We need to make it water decompose. We need to use electrolytic process. Means current passing. Current. By absorbing current, it is getting decomposed and it is forming to H2 plus. O2. This year, possibly they asked this question based on diagrammatic. We will discuss while discussing about decomposition reactions. Next, so like this, all decomposition reactions are endothermic. AgBr, silver, bromide getting decomposed by absorbing sunlight and becoming silver plus bromide. Like this, all decomposition reactions are endothermic reactions. Next, N2 plus O2. N2 plus O2. It is a combination reaction. Example, these both are combined by absorbing energy. We need to supply more energy to break down the nitrogen bonds and oxygen bonds, then only it will take place in the reaction. So, it is also part of endothermic reaction. N2 plus O2 gives rise to 2NO. It is also belongs to endothermic reactions. So sometimes after the reaction, they used to mention plus delta H, plus delta H. Plus symbol is that means endothermic. Minus delta H are the means exothermic. Okay. Next, photosynthesis process. Photosynthesis process. Photosynthesis process means plants preparing food. Green pigment, leaves, it have water molecule in it, and it will take a carbon dioxide, it will absorb carbon dioxide. What we are exhaling, carbon dioxide. In presence of sunlight, the food is getting prepared. It becomes like a C6H12O6 plus oxygen gas liberate. So plants taking carbon dioxide in presence of sunlight, it is preparing food, glucose and oxygen. This glucose and oxygen we are using. Okay. So this is also part of endothermic reaction. This is which reaction? Photosynthesis reaction. Photosynthesis reaction. These are the some examples for endothermic reaction. Now come to exothermic reaction. For exothermic reaction, we can say note, note all combustion reactions, all combustion reactions, all combustion reactions are exothermic reactions. All combustion reactions are exothermic reactions. One more note. Note 2. Generally, displacement reactions also. Displacement reactions. Generally, displacement reactions. Also considered as exothermic reactions. Okay, so all combustion reactions, almost all displacement reactions are exothermic reactions. Here I said combustion, not combination. Combustion is different, combination is different. You will get to know the clarity upcoming video while discussion about types of reactions. Okay, now examples. Best example, magnesium burn in the presence of oxygen. It forms magnesium oxide. Magnesium oxide. While burning, it liberates dazzling bright light. Dazzling bright light. Okay, that is what it is. Part of exothermic reaction. Next, sodium. When we placed on water surface, it react very vigorously and liberate energy. It react with the flame, that much vigorous nature. At the time also, it is a exothermic reaction. Next, here just I am giving some examples. Again, types of reactions we will discuss now. There also, I will give more and more example. Now, a respiration process. A respiration process. Respiration process means which is happening in animals and human being. Opposite to the photosynthesis. In photosynthesis, plants having green pigment which contains water and with reaction with carbon dioxide and prepared food in presence of sunlight by observing sunlight. So that is we call endothermic reaction. Respiration, it's a reverse opposite to the photosynthesis. Food contains glucose C6 H12 O6. What we are eating food, it contains glucose. We are inhaling oxygen. We are inhaling oxygen. These both are participate in the reaction and liberate water, carbon dioxide, and energy. And energy. That is what whenever we take food, after some time we will feel energetic because this is the respiration process going on. So, yeah, from the reaction, energy released. That energy we are using to do work. That is because respiration process. So, energy released now, exothermic reaction. Next, next change is uh, formation of precipitation. Formation of precipitation. Fifth change. Formation of precipitation. Formation of precipitation is nothing but insoluble substance formed in the product. Insoluble substance. Insoluble substance formed in the product. It is called formation of precipitation. Example: silver nitrate silver nitrate react with sodium chloride. Here, to make it a precipitation, silver chloride precipitation, I am taking sodium chloride. You can take any chloride with metal. Okay? Magnesium chloride you can take, potassium chloride you can take, zinc chloride you can take, or HCl hydrochloric acid you can take. Any chloride. Any chloride. Chlorine should be there. Yeah, nitrate, silver nitrate. Both are in aqueous medium. What is meant by aqueous medium means the salt when we add it to the water, that solution we call aqueous. Aqueous, silver nitrate and silver chloride. Because in aqueous medium, these salts dissolve and split into ions, easy to exchange their ions and forming new product. When this both mix, it forms AgCl, silver chloride. Silver chloride is an insoluble substance settled down, precipitate, PPT, means precipitate. Or downward arrow symbol we will use, plus the remaining NaNO3 in aqueous. See here, when we add it to water, it will split into Ag plus NO3 minus, Na plus Cl minus, exchanging their ions when we mix both. So this silver, this chloride, in this positive, in this negative, in this positive, in this negative, exchanging their ions and forming like this product. Next, so this precipitate is in white color. The color of precipitate is white, white precipitate. Next, barium chloride react with sulfuric acid. Not only sulfuric acid, any sulfate, H2SO4 or Na2SO4, ZnSO4, like that, any sulfate we can use here. Both also in water, aqueous medium, Ba2 plus, Cl minus 1, hydrogen plus 1, sulfate ion minus 2. These charges ions are given in first video itself. Observe. Now exchanging the ions in this plus in that minus, in that plus in this minus. Ba SO4 HCl. Like that. Ba SO4 barium sulfate. Insoluble substance, white precipitate. It is also white color, white precipitate plus H2, 2 HCl. 2 hydrogens, 2 chlorines are there, 2 HCl will get it. In aqueous medium. If you take Na2SO4, NaCl will form. Next, lead nitrate, PbNO3 twice, react with potassium iodide. Both also in aqueous medium. It turns into lead iodide. Lead iodide, which is in yellow color precipitate. Yellow color precipitate. PbI2 plus KNO3 potassium nitrate. These are the best examples for precipitation. Okay. Thank you, children.